Topic 3.1 Periodic Table. The elements within the periodic table, the elements are arranged in order of increasing atomic number. So like they increase from the hydrogen and it increases as you go down and to the right? And there occurs a periodic repetition of the physical and chemical properties. So when you look at these elements, okay, based on how they grouped or where they're located in the periodic table, they have a similar physical and chemical properties. So let's talk about the group and period. So group means elements with the same number of the valence electrons and the ones that because of that they have a similar chemical and physical properties, and when these elements get together we say they are within this group, okay, their own group or within their family, okay. And the vertical column of the periodic table are called group, okay. So these guys are called the groups. And period means element with the same outer shell, means like energy level, the last energy level. So we now know what is meant by group and period, right? But then we also need to know how to separate the elements within the periodic table in terms of the metals, non-metals, and metalloid, okay? So the ones that are colored in yellow within this periodic table are non-metals, and the elements that are colored in white are called metals, and the elements that are colored in purple are called metalloid, okay. So generally you can find the metals in the left hand side of the periodic table. You can find the non-metals in the right hand side of the periodic table, okay. And you can find the metalloid along the diagonal line, stepped diagonal line within the periodic table, okay. So let's talk about the metals, okay. Metals are good conductors of the heat and electricity, okay, and we can hammer the metals and turn them into a thin sheets, and also they're ductile, means they're capable of being drawn into wires, and they're very shiny, okay, and they tend to lose the electrons, okay, because the metals have a positive charges. They have a positive charges, okay, means they're cations, right? And metal oxide form basic solutions in water, okay, remember this. Metal oxide form basic solutions in water, and when the mercury dissolves the other metals, we call that newly formed compounds amalgams, okay. And non-metals, they're negatively charged, okay. That means they're anions, okay, and they are poor conductors of the heat and electricity. Typically, non-metals gain electrons in chemical reactions. They are getting reduced, okay, whereas metals lose electrons. So non-metal oxide tend to be basic when dissolved in water. Metalloid are the ones that are close to the step diagonal line, which have both metallic and non-metallic properties, so we can sometimes call it semiconductors, and tend to have semiconductive properties and form amphoteric oxide. So we now need to know the names of the different groups within the periodic table, okay. So the first group that we're going to talk about is alkali metals. Alkali metals are located in the group 1, on the periodic table, and they're called alkaline metals because they are react with the water to form an alkali solution of the metal hydroxide and hydrogen gas. Means if we have like sodium from group 1, okay, and when the sodium react with the water, which is liquid, they form a hydroxide, metal hydroxide, that means NaOHAQ, and form hydrogen gas. Okay, and they react by losing outer electron to form the metal ion, and they're good reducing agent because they can readily lose an electron. Means, so think about sodium. Okay, let's draw the atomic diagram for sodium. Okay, so sodium, let's say there's a nucleus. Okay, sodium, let's say like sodium nucleus, this, and it is located on period 3. That means it has 3 energy levels. So energy level 1, okay, and energy level 2, and energy level 3. Okay, and sodium has 11 protons, means it has 11 electrons. Okay, so I'm going to say 2 electrons in energy level 1, 8 electrons in energy level 2, okay, that means there's only 1 electron in the last energy level. Okay, because we have just 1 electron, right? It doesn't, in the energy level 3, it doesn't really take a lot of energy to remove this electron. That's the reason why we can lose this electron very, very easily. Okay, that's the reason why we consider the alkaline metals as the good reducing agent. Okay, alkaline earth metals, they are group 2 on the periodic table, and they're abundant metals in the earth. Okay, and they are not as reactive as alkaline metals. Means they don't really react with the water. Okay, but they more like they react very slowly with the water. Okay, that's the reason why when we look at them, it looks like they're not reacting with the water. Okay, and higher density and melting point than alkaline metals, and they're very soft silvery metals, and they're tarnished readily in air. Okay, and they react slowly with the water, I already mentioned, and they're difficult to separate because all have 2 effective balanced electrons. So I already told you, when you have a group 1, okay, it has only 1 balanced electron in the outer shell. That's the reason why it's really, really easy to move. It's just 1 electron, right? But when you think about the group 2, okay, let's talk about magnesium from the group 2. Let's say this is the nucleus, energy level 1, energy level 2, energy level 3. When this happens, magnesium has 12 protons. It means magnesium atom has 12 electrons. Okay, so energy level 1 we get 2 electrons. Energy level 2 we get 8 electrons. Okay, and the energy level 3 we get 2 electrons. Okay, or when you have more electrons, it means it takes more energy to remove these electrons. Okay, so that's the reason why it's getting harder than group 1. Okay, and transition metals, they are located from group 3. Okay, group 3 to group 12. Okay, these groups are the elements within these groups are called the transition metals. They have a different valency and oxidation state. Okay, means also that means like they have different charges too. And they form colored compounds, and they form complex ions, and they also have a catalytic behaviors. Okay. And group 15 located on the group 15 from the nitrogen phosphorus. Okay, these guys are called the group 15 elements. Okay, and we also call it nitrogen family. And group 17, they are called halogens. Okay, halogens, they react by gaining one more electron to form halide ions, and they're good oxidizing agent because they readily gain an electron. Means, let's talk about the fluorine. Okay, fluorine has the 9 protons. Okay, has 9 protons, means fluorine atom has 9 electrons, right? Then let's say fluorine, this is fluorine's nucleus. Okay, and it has, since it is located on period 2, it has 2 energy levels. Okay, so energy level 1 and energy level 2. Okay, when this happens, the energy level 1 gets the 2 electrons, and the energy level gets the 7 electrons. Okay. Okay, and we all know the energy level can take up to 8 electrons, right? And means we are only 1 electron short from having full energy level, right? So just, do you guys remember the electron configuration from the topic 2, right? So since we are only 1 electron short from having full orbital, I should say it has much more will to gain an electron to have fully completed outer shell. Okay, so that's the reason why it is a good oxidizing agent. Okay, and they have 7 valence electron. All of the elements within the group 17 has the 7 valence electrons. The last one is the noble gases. They are group 18 on IBIC periodic table. They're sometimes called layer gases or inert gases, and they are relatively non-reactive, and also they are gas at room temperature. So each of them in this group 18 has 8 valence electron, means it has 4 outer shell. Okay, that's the reason why it's non-reactive. Okay, since it has everything, okay, it doesn't need to react to gain an electron or lose an electron to have a full outer shell. That's the reason why it's non-reactive. Okay, and also these guys are the only group that has all 4 subshells. Okay, that has all 4 subshells, S, P, D, and F. Okay, the last groups are lanthanides and actinides. They are these guys here. They are radioactive elements and part of the inner transition metals. Okay, they go over here, right? And their lanthanides and actinides are elements with the unfilled f orbitals. Lanthanides are all metals with the reactivity similar to the group 2 elements, okay? And actinides are all radioactive elements.